All right. So on the screen here, we have an isosceles triangle. Just like I mentioned from primary school and whatnot, right? So it's on the screen there, right? So in case you can't remember, an isosceles triangle, well, it has, well, three sides, obviously, and two sides have the same length, right? They have the same length. And one side usually doesn't have the same length as the others. The two sides that have the same base. Now, a lot of people associate the base with the underneath of the triangle. That's definitely not true, because you could have an isosceles triangle tilted to the side, like this triangle here. If I draw an isosceles triangle like this, right? And I tell you, these two sides with the stroke have the same length, then this would be a leg, and this would also be a leg. And the side that doesn't have the same length will be called your base, right? So the base doesn't always have to be on the ground, because I know in English, base means underneath or on the ground, right? But that's certainly not the case. And in an isosceles triangle, right, you have to be very, very careful. These two angles, the two angles touching the base, are always equal to each other. So these two pink angles are equal to each other. And in my original diagram, these two angles are always equal to each other. Now, you have to be able to calculate the missing angles quickly. You just can't say, all right, I will take 2 minutes to resolve the missing angles. For high school, you can't be so slow. So I just want to do some quick practice questions just to jog your memory. Because remember, this is just a revision of what went on in SEA, right? So I don't want to spend too long. So let's assume for my first question, this blue angle over here, right? Let's assume that this blue angle in the vertex here, where the two legs meet, let's assume that angle is 85 degrees. I want you all to calculate the size of one of the base angles very, very quickly, right? I'm giving you the vertex angle as 85. I want the value of one of the base angles. Remember, base angles, the ones touching the bases, are always equal in value, right? Degrees, right? That's general knowledge by now for you guys, right? All the angles in a triangle add up to 180. So if the vertex angle, right, is 85, you take 180 and minus the 85 degrees, right? So you have 180 minus 85. Let's see how much we remain with. 180 minus 85 is 95 degrees. So that remaining 95 is going to split evenly between the two base angles, right? Evenly, because the base angles are equal. So you just divide it by 2 to get the size of each one, which will give us 47.5. So this angle here is 47.5. Sorry for the bad handwriting. Remember, I told you guys I'm using a real crappy computer this morning, right? So my handwriting wouldn't be too neat, right? And a lot of people got that answer. All right. So like I said, you don't need to take down anything. You just need to make a mental note and try to send your answers on the chat as fast as possible. So let's try another question, right? Just for revision purposes, and we can move on to the actual Rule 6 and Rule 7. How about I do it in a reverse manner? If I come and tell you this angle here is 32 degrees. Look at this angle here. One of the base angles is 32. I want you all to calculate this yellow angle here, put a little question mark. Remember, this question mark angle is not the base angle. That's where the two legs of the isosceles triangle meet, okay? So what's the size of the vertex angle, given that one of the base angles is 32? This is not supposed to be too hard. No tricks really here, guys. So that means, right, if this base angle is 32, then without any calculation, the other base angle is also 32, equal. So if you add those two, 32 plus 32 is 64. We know a triangle is 180 degrees. So if these two add up to 64, if you minus it from 180 to get the balance, well, most people are getting it correct. This angle will be 116 degrees. You're just minusing what? 180 and 64, where the 64 is the 32 plus the other 32, right? Easy stuff. You're going to be doing this a lot today, but you got to be able to do it quick, because almost every question that you're going to see today, almost every question is going to have something to do with an isosceles triangle. The examiners love to mix circular theorems with isosceles triangles, right? That's just how the questions come, right? And one more thing just to make a mental note about. If, let's just say, in an isosceles triangle, let's just say that the vertex angle is 120 degrees. I just say, anytime you split the isosceles triangle, like the line goes straight down to meet the base. Any straight line coming straight down that's cutting the vertex angle, right? It will automatically cut the vertex angle into two equal pieces. In other words, here will be 60 degrees and the other portion will be 60 degrees, right? And you're going to be seeing that a lot today as well. You're going to have isosceles triangles. And if you look carefully or you use the imagination, you will see a line cutting the vertex angle. It's trying its best to cut the vertex angle into two equal pieces. So in a case like that, it will split the vertex angle into two equal pieces. You just divide it by two. Right? So with that in mind, let's move on to rule number 6. Right? So rule 6 starts with a circle, and you have a point from outside the circle, and you're drawing two tangents starting from point A. Another word from starting is originating. You will see most textbooks say the two tangents originate, that means start from point A. And anytime you choose any point outside a circle, it's always possible, possible to draw two tangents from that same point. You will always, if you use your imagination, you will be able to always imagine two tangents. Remember, a tangent doesn't go through the circle, like this second green line. It goes through the circle at 2 points. That is not a tangent. Don't ever make that mistake. A tangent just grazes the circle. All right. So what's going to happen now? Look at this. The 2 points where the tangents grazes the circle, point B and point C, right? I want you all to connect it. Let me do that a little bit better for you guys there. Right? Something just, remember guys, I'm using an old computer, so I'm a little shaky this morning, right? You see where it is point B here? Yeah, different color. I hate those colors. This is point B, where the tangent makes contact. And this is point C, where the other tangent makes contact. You notice when you connect A, B, and C, you get a triangle. But here what? There are so many different types of triangles in maths. It have isosceles, it have scalene, it have right angle triangles. It have so many different types of triangles. It just so happens whenever two tangents originate from the same point, and that's keywords, both tangents are originating or starting from the same point, and that point happens to be A. These two lengths will always be the same. Always. It's like magic. So the length from B to A is the same exact length from C to A, right? They have the same length. So if from B to A is 22 centimeters, C to A is automatically, like magic, also 22 centimeters. The pink line, he is not the same, right? He will always be a different length. So you guys probably kind of figure out what kind of triangle this is. This is an isosceles triangle. And this here is the vertex angle. And these two pink angles, oh, I can't find the pink marker. Right. These two angles here are the base angles. So this line comes like the base now, right? So I'll put B for base, but I'll put base here. This is a base angle and this is a base angle. The two base angles will always be equal. So this situation will always give you an isosceles triangle, right? Always, no matter what. So everyone update, put in little annotations. I put in as well, right? Which one is the vertex angle? Which one is the base angle, right? You always get an isosceles triangle in this case. Now, there are two versions to Rule 6. There are two versions, right? Sorry about that. Right? I will put Rule 6 in words just now for you guys. Oh, I have it underneath there. It now appeared. That's Rule 6 in words. Tangents to a circle originating from the same point have the same length. So in other words, they're already trying to say this is an isosceles triangle, because if these two lines are the same, then you always, if you connect the B and C points, you always end up with an isosceles triangle. Most textbooks will leave out the words isosceles triangle. They will just say it up to here, that these two lengths are the same. And then by extension, you know it will create an isosceles triangle, okay? When you finish, just raise your hands and have a slightly different version to Rule 6 I need to show you guys, right? Right. So here's what's going to happen again, right? We're going to draw two tangents starting from a point outside the circle, this point A again. So I draw my two tangents, bam, bam, right? But this time, I am not going to connect. I'm not going to connect these 2 points. Oh, that's a real terrible straight line, but you all get the idea, right? So I'm not going to connect this to get an isosceles triangle. Instead, I'm going to take this point, where point B is, and connect it to point O, the center. And then I'm going to connect it to over here. Now, that's not a triangular. I mean, it looks triangular-ish, but that's not a triangle. That's clearly a very weird-shaped quadrilateral. One side, two sides, three sides, four sides. Now, don't get me wrong. This length and this length will still be the same, right? But you'll realize this is kind of like Rule 5. Isn't this a radius? Oh, my God, that's the word radius, okay? If you look back at Rule 5 from last week, you'll realize the angle between a radius and a tangent is always 90 degrees. The angle between, here's a next radius. A circle can have more than one radius. Radiuses just start from the center and head towards the circumference. So over here, the angle is 90 degrees again. So here's my question, right? If I tell you this angle is 22 degrees, I just say, and I'm going to make it a little bit bigger than that. Let's say this angle here is 48 degrees. Do you all think you all can find the size of this missing angle here? So this question is like a mixture of Rule 5 and Rule 6. What's the size of that angle in the middle, given all the information I just gave you? That's 48 degrees, by the way. Like I said, for those who now came in, My handwriting is going to be a little bad today. I'm using a really, really old computer, like a ridiculously old computer. Remember, this here is a quadrilateral. All the angles in a quadrilateral, no matter how oddly shaped, adds up to 360. So if here's 48, and here's 90, and here's another 90, right? That's the symbol for the 90 degrees. Let's add up 90, 90, and 48. I have a trusty calculator here. 90 plus 90 plus 48. I'm getting 228 degrees. So if I minus it from 360, I'm going to get how much? 132, right? But the examiner could move forward and ask you a slightly harder question, right? Slightly harder question. So the question might start up like this. You try to find this missing angle, and we got 132. And then the examiner will add in a next line. They will connect point A, they got totally different color, blue, point O to point A. And then they will ask you the size of this angle here and the size of probably this angle here. These are very simple questions. Because this length and this length is the same, you get like a symmetrical shape now. You get one triangle on top and one triangle underneath, which means this 48 gets divided exactly by 2. So 48 divided by 2 is 24 degrees. And if they ask you for this half here, the 132 would get sliced exactly in half. So 132 divided by 2 is, I can't do that in my head. 66. You would think I'm a maths teacher. Anyway, right? So you're going to be seeing that situation today. I like to call this rule a kind of merger between Rule 5 and Rule 6. But technically, it's more Rule 6 because of the two tangents starting from the same point, right? Everyone take down this diagram for me now. Exactly how I have it there, right? You're going to get plenty practice today, guys. Ton of practice. Right. So somebody just wants a few more seconds. But this is just a neater version of what I just did, right? So with that in mind, let's take a little small break here to earn some points. It's because we just finished Rule 6. The last rule is the hardest one to explain. It's like I will explain this like literally 10 times, and class, not everyone in the class will get it, right? It's just one of those rules that give a lot of problems, right? So I kind of came up with a different way to try to explain it, and you guys are the first guys to hear this explanation, so I hope it works out. Let's say that you go into a house, right? You all know what an attic is in those American houses or houses away. In the ceiling of the house, you know how those American houses, they don't already have flat roofs. Their roofs are like a steep triangle, and they usually put an attic up there to store like old stuff and whatnot, right? So how Rule 7 works, sorry. Let's say that this is the door of the house, right? And somebody now walks into the house. So you have someone standing over here, right? It's like a little horror movie, right? So they're standing on the wooden floor. Now, above him is the attic. And below the floor, right, is the basement. The basement is underneath the ground, right? So there's a troll that lives in the vertex or the very, very corner or highest point of the attic. And in the basement, there's another troll. Well, a kind of goblin troll, whatever he is, right? Now, you see the floor that the man is walking on? That's going to be the chord, represent the chord of the circle. You remember what a chord of a circle is? Like if you have a circle, a chord is a straight line that goes across. This chord is supposed to represent the floor the man is walking on. Now tell me something. There's a goblin above the man, and there's a goblin below the man, right? One is above the chord. Well, I shouldn't say above, because if we turn the screen upside down, the better way to say it is that there is a troll on one side of the chord or floor, and there's another troll on the other side of the chord slash floor. Can these two trolls see each other? Can they see each other? Yes or no? Can they see each other? The answer is no. They cannot see each other because what's blocking their point of view? The floor. The floor is in between the two of them, right? These trolls represent angles. This troll is one angle, and the one below the floor is another angle. In a case like this, the two angles are always equal. They're always bad handwriting again. Sorry about it again. The two angles, the two trolls are always equal. Always, right? It's like magic, right? But I know you are going to need to see this in a proper circle in a little while, okay? So do me a favor now. Yes, I want you to draw this crazy diagram with the trolls exactly like how I have it and take down this preposterous note here, right? Take my advice. Rule 7 is the hardest one for me to explain. And I have to find silly ways of trying to explain it. Every year is a challenge to explain this one. When you're finished drawing and writing it down, I will show you a proper diagram now with the circle. And I will let you know if you're seeing, I will ask you, sorry, if you're seeing the rules in the scenario. All right. Now, it could be the other way as well. Like the house could turn upside down. Let's say there's a huge earthquake and the house turns upside down. Now, in a case like that, I don't want to make you draw this, right? But in a case like that, the attic will be down here and the basement will be up here. Now, let's just pretend somebody with a like Godzilla takes the house and turns it upside down, right? These two trolls, these two angles will also be equal to each other. You don't have to draw it back, right? So let me show you how this applies to the actual circle. This here is the actual rule for number 7, right? But I want to explain it first. In this rule, it will have a chord. Look at the chord here, right? The chord starts here and ends on the other side of the circle. Where the chord touches on one side of the circumference, there is a tangent. Look at it properly. There's a tangent grazing the circle over here. And there is an angle starting at the beginning of where the tangent makes contact. The line goes, it must hit the circumference, and it bounces back to the end of the chord. Remember, this comes like the floor where the person was walking. So I'm going to draw back the person over here, right? There's a person over here. This here is the floor. There will be an angle between the chord and the tangent. That's the first troll. This angle here is where the first troll lives. And you see the kind of attic here, where the triangle kind of converges. Here's the attic. These two angles will always be equal. The angle underneath the floor and the angle in the attic. But look at the situation. It must have a chord, it must have a tangent, and then the attic kind of stands on the chord. Like if you want to pretend this is a foot here and this is a foot here, and you have somebody standing here, right? Their foot is what? Extending to either end of the chord. So if this angle is 30 degrees, using or stating rule 7, this angle is automatically 30 degrees between the chord and the tangent. It's like magic, right? Draw this super, super neat and take down the official Rule 7, right? Take down everything on the screen, in other words. When you finish, raise your hands, right? And with that in mind, we're finished with all the rules. We know Rule 1 to Rule 7. This is what CXC requires of you, right? To know these 7 rules and then apply them to various questions. Oh, and by the way, there's another scenario. There's two versions of this. Look at this. If this goblin and this goblin are equal because they cannot really see each other, you notice they're kind of on opposite sides. Isn't there another way of looking at it? Isn't there another chord over here? Which means there's one goblin underneath the floorboard here, and this here is another attic. If you look at it, these two are equal to each other, and these two are equal to each other. So you have to keep your eyes out now. It doesn't, when you draw out the whole scenario, there could be more than one pairs of basement and attic. So the two blue trolls are equal to each other, and the two yellow trolls are also equal to each other. If you could draw in these two here now, one here and one here, draw a slightly different looking troll, if you can, right? Like I said, don't worry too much if you're a little confused about rule number 7. We're going to have to do plenty practice on this. He's the hardest one to grasp, the hardest one. Right? So if this yellow troll is 70 degrees, on the other side, underneath the chord, because this is a chord, you have another troll or another angle who's also 70 degrees. So the two yellow match up and the two blue trolls also match up. Right. All right, let's go. Time to move on. Right? And this is here from a different perspective, from the upside down perspective. So in other words, if the tangent is on top, and here is what? Here's the chord. Here's the floor, right? There must be an angle between the floor and the tangent, and kind of on the opposite side in the attic, there will be a corresponding angle. So if here's 60 degrees, over here is 60 degrees. Also, if you want to pretend here is the chord, right? Then there will be an angle between the chord and the tangent here. And who is standing on that green chord? There will be an attic here. So these two green would be equal, and these two yellow will also be equal, right? Those two blue trolls will be equal, and these two yellow trolls will also be equal. I needed to draw it from the upside down perspective as well. Draw back this diagram. It's oriented a little bit different, but you need to see which angles match up. Okay? When you finish drawing that new one, raise your hands and let's do some practice questions. So here's our first question, right? Here's our first question. Well, actually, this is a real easy question. I'm not too sure if you all see it, right? It's a little bit too easy. Do you all realize if I put a question mark here, what would be the size of that angle? What will be the size of that particular angle? I'm not going to ask you to draw this. Just this one too easy. And here would also be 59 because here we have a tangent and we have what? a chord here, right? There's an angle between the tangent and the chord. And standing on that same chord, but standing kind of upside down, is the other troll on the opposite, kind of like on the opposite side now. So using rule number 7, that would also be 59 degrees. All right. Nothing too great over there. All right. Let's move on to something harder. I'm not too sure why I put that. All right. So let's do some practice questions here now. I would like you all, there are more than one ways to do this. I want you all to find this angle over here. Now, there's more than one ways to do it. And we're going to see if both ways will give us the same answer for that angle. I want everyone to draw that diagram neat. You'll notice this is point O. So this is the center of the circle. It is the center of the circle. I want you all to, after you draw it, I want you all to find that missing angle using 2 different methods. I want you to kind of like investigate rule 1, rule 2, rule 3, all the way to rule 7. It have 2 ways, like I said, to get out that angle. Let me know the 2 ways. Right? Giving you a full 5 minutes to think that one through. This is a very important thinking exercise. And I know last week, I was working out a question. It was to the end of class. It was the last question. And I used this hard method to figure out the missing angle. And when almost everybody left, one student stayed back and told me, but sir, there was an easier way to get out the question. And that's going to happen a lot in these types of questions. You're going to realize sometimes there's 2 ways to get the same answer or 3 ways to get the same answer. The truth is the examiner doesn't care which method you use to get the answer. Once you get the answer and you can explain how you got the answer, you get full marks. Anyway, guys, 5 minutes. The first thing I would do was look at rule number 3. Now, we're going to have to turn back here a little bit, guys. You got to help me out. I want everyone to turn back to rule 3 so you physically see it in front of you and refresh your memory. Remember, rule 3 has something to do with the diameter of a circle. And I told you rule 3 was the easiest out of all the rules. Have a look at rule 3 there, right? Rule 3 says if you have a diameter and from A to C is a diameter, because it's starting from A, one side of the circumference, going through the center to the other side. If you have an angle that starts at the beginning of the diameter, it hits the circumference, it does hit the circumference at point B, and it bounces back to the end of the circumference. It says the angle touching the circumference is automatically 90 degrees, right? So that means ACB is a right angle. It is a triangle at the end of the day, but also a right angle triangle. And all the angles in a triangle always add up to how much? 180 degrees. So to find angle A, you just take the 90, you add it to 54. Let's see how much I get here. 90 plus 54 is 144 degrees. To get the remaining angle, you minus the 144 from 180. Let's see. You get into the 6 degrees. How much people was able to get to the 6 degrees over here? Raise your hands. To me, that would have been the easiest way. That is just my opinion. But then somebody else might come and say, well, I seen a different way of getting out this same question. Let's have a go at it. Let's try it a different way, right? So the other person comes now and he says, hey, This looking kind of like Rule 5. Remember what Rule 5 was about? Let me refresh your memory. Rule 5 says, if you have a radius, this red line is a radius, right? From the center to the circumference. And if you have a tangent, that's how make that a little thicker. And if you have a tangent, that green line is a tangent, the full angle between a radius and a tangent, according to rule number 5, is 90 degrees. So this whole angle here, from this red line all the way to the green line, is supposed to be what? 90. So, and we could find this missing angle over here. If the whole thing is supposed to be 90 and this portion is 54, then the missing piece here is what? 90 minus 54, right? Let's make sure we get into the 6 there. 90 minus 54. You're going to get 36. So this angle here is 36 degrees. But I ask you to find this angle. So after you find this angle using rule 5, you can apply rule 7 only after. I'm not too sure if you're seeing rule 7 here. Look, no, in the vertical line there. Isn't this a chord here, this yellow line? I put C for chord, right? Isn't that a chord? There's an angle underneath the chord, and you all see a kind of attic over there. Isn't this the attic angle? Isn't the angle in the attic and the basement where the two trolls live, aren't they equal? So if here is 36, then over here is also 36. That's a second way of getting the same answer. But obviously that's the harder way, right? I would have chosen the first one where we just use rule number 3. But it's a good, even though I showed you a harder method, sometimes it's good to practice the harder method because it helps you understand the topic better. It helps prepare you for harder questions down the road. All right, so that's 2 ways of getting the same answer. Let's get ready to move on. You don't have much to take down here, right? This is just for me to talk and practice a little bit and whatnot. All right. So let's have another one just to, to take the stress off. Which one do you prefer? He's going to ask us a question. All right, I have no idea what he's going to ask us. Oh, it's 2 cars. Let's say somebody shows up by a house and said, hey, you have just won a car. And they put 2 options in front of you. You can walk away with one of them. Which one are you going to choose? That cool, classic green one? I love how that green one looks. Or are you like a yellow car person? Well, which one appeals to you here? Think on it. And we're gonna run the polls and all. All right, so you have a big question to do now, right? This is a practice question for you. Draw that diagram. Get that dot at the center is the center. Remember, O is always the center. You have 4 angles to find. Now, I haven't given you enough time to do this. I've given you 10 minutes. Draw a super neat diagram. Don't draw it too small. And then attempt the questions. Remember, if it gives you 3 letters, you're always trying to find the middle letter. Just trace the 3 letters, right? A, O, P. Right? I could probably help you out and let you know which angle you're trying to find. So I'll write A, B, and C in the angles. A, O, P. That this is A. Q, A, O. Q, A, O. This is B. C is Q, P, C. Q, P. Where's C is? This one, not seeing C. Oh. Q, P, C. This is part C. That's the angle I want you to find. And D, Q, A, P. Q, A. All right. The last one, Q, A. they don't have a line connecting from A to P. So you have to put in that line. QAP is this entire angle here. That's for part D. Right? So I hope that helps a little bit. I'm giving you 10 minutes. It doesn't matter if you get it wrong. And guys, I have these questions. I expect you to get the majority of it wrong. But you need to try and get it wrong. You just learn a lot by getting things wrong. If I just come and give you the answers just so and you didn't try it, you will learn nothing, right? This is problem solving. You have to see patterns, and it takes practice and trial and error to develop that skill. Good. Anyway, let's go. This is going to be torturous. A, right? So I'm going to do, obviously, do one at a time. So the first part is AOP. AOP. That was this angle they were asking for. Now, for this one, remember I told you the hint was you will use rule number 5. Rule number 5 says if there's a radius and a tangent, look at that orange line. That orange line is a radius. And this pinkish line, not too sure that's pink or purple, is a tangent. So the angle, according to rule number 5, between the radius and the tangent is 90 degrees. So there's a 90 degrees on this side. But there's another radius on this side as well. The angle between a radius and another tangent on this side is also 90 degrees. And they gave you this angle as 52. Now, don't get me wrong. Some of you might be seeing rule 6 here. This length and this length is the same. But knowing that this length and this length is the same doesn't really help you with the question too much because we have enough information to get it out. We know here's 90. We know here's 90. We know here's 52. All the angles in any quadrilateral, even if it's weird shaped, is 360. So we're going to add 90, 90, and 52 and minus it from 360. If we do that, right? Oops. Right? We'll get 128 degrees. How much people got the 128 without my assistance? I have the full explanation here. So you have to write out this from here. You have to write it out. That's exactly how I would write it in the exam to get my full marks. And here's the sad part. For writing out that entire thing, to get only part A, you know how much marks you're going to get? 2 measly marks. But you got to real work for them 2 marks. All right? Clearly. So you can see in the explanation here, I take any 360 and I'm minusing the 90, 90, and 52. Or you can add them up first and then minus it anyway. But either way, you're going to get 128. Right? Notice I just didn't say rule number 5. The examiner expects you to write out in words. What is your rule number 5? Okay. When you finish taking down everything there, update your diagram after. If you get here as 128, write in the 128. Raise your hands when you finish. Raise your hand. All right. So moving on to part B now. Now, it's really important. I know I mentioned it just now. You have to keep updating your diagram as you get answers. Fill it into your diagram because part A might help you with part B. And if it's not directly in front of you, you're not going to see or be able to move on to the next part. Right? So I'm moving on to part B. Now remember for part A, I got here as how much degrees? 128. I know here's 90 degrees and I know here's 90 degrees. So I'll fill it in. Who knows? That could come in handy. And we know this angle is 115 that was given to us. So in part B, they're asking us to find angle QAO. It's the middle letter. Q, trace the 3 letters, Q, A, and O. It's this angle here. Now, if you look carefully, let me draw back that scenario. That's this blue line here, Q, A, and the 2 orange lines. Isn't this a radius and isn't this a radius? Radiuses start from the center and go towards the what? Circumference. Two radius must have the same length. If it's the same circle, then both radius by default have the same length. So this here is an isosceles triangle. But we know this angle and this angle will be the same. Those are the base angles. So we know these two angles are the same. But we don't have this angle here. But it's easy to find it. Look at this. If I have three orange lines like this, and here is 115, this I kind of drew back this scenario, and I know here's 128. If I complete this angle here, isn't that a full circle? All the angles in a circle add up to 360. So if I have 115 and 128, I could just simply add these two and minus it from 360. So let me do that, right? 115 plus 128. When I add these two angles, I'm getting 243. I just have to minus it from 360. And I'm getting 117. So this angle here is 117. Okay? So if I know here is 117, remember at the beginning of class, I asked you all, I reviewed how to find the missing base angles. If here is 117, we just minus it from 180. 180 minus 117, right? Will give us 63. So that 63 is going to be shared equally with the two base angles in the isosceles triangle. So take the 63 and divide it by 2. And we get into the 1.5 degrees. Sorry for the bad handwriting. So this angle here is 31.5 degrees. How much people got that? I have it in writing just now. Don't worry, I have it obviously in a note form just now. So that angle is going to be 31.5 degrees, right? So let me put all of that in writing now, neatly for you guys. Look, the full explanation there. Read it through. Everything that I just said, I put it in a nice, neat sentence for the examiner, or a paragraph. Read it through, make sure you understand it, and then write it down, okay? When you finish writing it down, raise your hand. Part C. Right now, I'm going to have to update my diagram, right? All the missing stuff, I want to put it in because it could help us for part C. So this is what we know so far, right? We know this angle here is how much? 128. We know here is how much? 117. And we know this angle is 31.5. And this angle obviously will also be 31.5 because base angles in the isosceles triangle are equal. Right, so I have some information in front of me. Next part is asking me to find angle QPC. QPC. That's this angle here. All right. Now, how are you going to do this? All right, this one should be easy. You all notice there's another isosceles triangle here. From Q to P to O. This here is another isosceles triangle because this radius is equal to this radius, okay? So if here's 115 degrees, and it's real easy to find this angle here, you take the 115 and minus it from 180. So let's do that. Let's take 180 and minus it from minus 115 from it. Because these two base angles will be equal to each other. So let's minus it. 180 minus 115. I'm getting 65 degrees. That 65 is going to be shared equally between the two base angles. So divided by 2. I'm getting 32.5 degrees. Now, this angle is 32.5, but they didn't ask us to find this angle, the what is kind of purple angle here. Do you all see rule number 5 there? Well, let me highlight it for you all. The angle between a radius and a tangent is 90 degrees. So if this whole angle between the two blue lines, the radius and the tangent is 90, right? If this portion is 32.5, and to find the portion we're talking about, we have to take the 90 and minus the 32.5. That will give us this portion here. It will give us this portion. Minus 90, and we're going to get 57.5. Okay? That is how we get it there. Right? But I have to put that in writing for you all. All right? That's a hard one to explain. Look, I have it there. Read it through. Make sure you're seeing those ice. The key to this, everything was boiling down to isosceles triangles in this particular part of the question. And then finally, using rule number 5. Read and write it down. Now, when you finish, raise your hands. Remember. All right. So the last part, D, asking us to find Q, A, P. But the problem with this one, they didn't, when the question was originally written, they did not connect A to P. They did not. So for part D, and this happens a lot in CX here, you have to draw in the missing line. So you trace the 3 letters, Q, A, P. Q to A, but there's no line going from A to P. So you have to physically draw in that line, add it in to the question. Otherwise, you won't get it out. So they're asking you for this angle here, QAP. Remember that this angle here we just got was how much? 57.5. Sorry, it's not a hard question. It's actually a very easy question. It's just rule number 7. You all seen it there? This green line is the chord. You have an angle between the chord and the tangent. Look at this purple line. And then you have an angle standing on the same chord. This is where one troll lives, and this is where the other troll lives. So both of them are equal to each other. Right? I made a small mistake here. It's supposed to be what? 57.5 degrees. All right? That's straight out of rule 7. Make sure you understand it. It's a detailed explanation for the examiner. When you finish writing it down, raise your